In section 5, we are going to talk about right triangles. So a lot of applications that you might see with triangles are going to involve right triangles. It's a very common thing. So what we're going to review is how you solve for right triangles. And when we talk about solving right triangles, we're talking about solving for missing side lengths or angle measures. So if you're solving for missing sides, there are two methods you can use. The first one is the Pythagorean theorem. And we use that if two side lengths are known. So if you know two of the sides and you're trying to find the third, you can use the Pythagorean theorem. The second method is to use trigonometric or trig ratios if one side and one additional angle are known. So if you know one side and one angle, then we have to use trig ratios to solve for the other missing sides. Then there's also solving for missing angles. If you know two angles, you can just subtract those from 180 and get the third one. If you don't, then we use something called inverse trig ratios if two sides and one additional angle are known. So if you know two sides and one angle, then we use what are called inverse trig ratios to solve for the missing angles. So just to review our trig ratio, so in your right triangle, the three sides are known as the opposite, adjacent, and hypotenuse. Now, opposite and adjacent are based completely on which angle you're looking at. The hypotenuse is always the same side no matter which angle you're looking at. So I have my right triangle here. Angle B is my right angle. The nice thing is the hypotenuse is always opposite our right angle. So that's the one that is always the same, is our hypotenuse. The opposite and adjacent sides are based on what angle you're looking at. So if I'm looking at angle A, the opposite side is the one directly across. And the adjacent side is the side that's next to it, but not the hypotenuse, because technically the hypotenuse is also adjacent. If I'm looking at angle C, its opposite side is going to be side AB, and its adjacent side is the one directly next. So opposite and adjacent are based solely on which angle you're looking at in the triangle. That is not the right angle. So it's very important here that we are talking about the angle that is not the right angle. So then for our trig ratios, there are three. The first one is sine, which is opposite over hypotenuse. We've got cosine, which is adjacent over hypotenuse. And then we have tangent, which is opposite over adjacent. The other type of right triangles we have are something called special right triangles. And there are two special right triangles that we are going to talk about. The first one is a 45-90 special right triangle. And in this case, two angle measures, you have two angles that measure 45 degrees, and you have two legs that are the same, which we usually use the letter X to denote that. And the two legs are the two sides that are not the hypotenuse. The hypotenuse is your leg, which is the value of x times the square root of 2. So if I were to draw a picture of this, I have my right triangle, I have 45 degrees and 45 degrees, and then I have my two legs that are both length x, and then my hypotenuse, which is x times the square root of 2. The other special right triangle is called a 30, 60, 90 special right triangle. So that's where one angle measures 30 degrees and the other measures 60 degrees. Obviously, your right angle is your right angle. Your shorter leg is denoted by x. Your longer leg is x times square root 3, and your hypotenuse is 2x. So the 30, 60, 90 is a little bit more of a difficult special right triangle, but it still has a relationship. So in our 30, 60, 90, I have my smaller angle that's 30 degrees and my larger angle that's 60. So the shorter leg is always the one that's opposite the 30-degree angle. So that's x. The longer leg is across from the 60-degree angle. So that's x square root 3. And then my hypotenuse, always across from the right angle, is 2x. So we're going to put all of this together to solve for missing side lengths and or angle measures in our right triangles. So in our first example, we have triangle DOG, and we know two of its sides, 14 and 5. And our right angle is going to be angle O. So the first thing I'm going to do is solve for my missing side, which, because it's directly across from O, technically it should be named side O, but I don't like to use O when I'm solving for side length, so we'll just go ahead and call it C since it's our hypotenuse. So our Pythagorean theorem is going to allow us to solve for our hypotenuse, which is a squared plus b squared equals c squared. It does not matter which sides you plug in for A and which you plug in for B. So I'm just going to do 5 squared plus 14 squared equals c squared. 5 squared is 25. 14 squared is 196. Then 25 plus 196 gives us 221. Then we'll take the square root, and we get that C has a length of 14.87, and then we know our sides are in millimeters. So that's our missing side. Now I want to solve for my missing angles. So we have angle D and angle G in our triangle that we don't know. And I only have to use inverse trig ratios once, because once I know two of my three angles, I can just subtract from 180. So when it comes to choosing which two sides to use to solve for my missing angle, I never want to use a side that isn't a whole number or given to me. So I don't want to use my hypotenuse here. Because I had to round to find the length of my hypotenuse, it is not a good choice to use to solve for my missing angle. I'm going to go ahead and solve for angle D. So I'm going to use the 5 millimeter side, which is opposite from angle D, and the 14 millimeter side, which is adjacent. So the trig ratio that uses opposite and adjacent is tangent. So we're going to say tangent of D, since I don't know what angle D is, has to equal 5 over 14. So to solve for the measure of angle D, I take what's called the tangent inverse of both sides. So D equals the tangent inverse of 5 over 14. So in the calculator, you hit second and then tangent, and it'll give you the little tangent with the little -1, 5 over 14. I hit enter, and I get that the measure of angle D is 19.65 degrees. Now that I have angle D, it's very easy to solve for angle G. I'm just going to do 180 minus 90 minus the angle I just found, 19.65. And we get that the measure of angle G is 70.35 degrees. In our second example, we have triangle CAT. Our right angle is at T, and we have that angle C is 54 degrees. So the first thing I'm going to solve for here is my missing angle A, because it's very easy to solve for. I know two of my three angles. We just do 180 minus 90 minus 54. And we get the measure of angle A is 36 degrees. I also know two of my side lengths. So to solve for my missing side, which I'm going to go ahead and name T since it is opposite of angle T, and typically we do use lowercase letters to name sides when we're naming them opposite of their angle. We don't use the capital letters because the capital letters indicate an angle measure. So we're just going to use the Pythagorean theorem. 12 squared plus 18 squared equals T squared. 12 squared is 144. 18 squared is 324. 144 plus 324 is 468. Take the square root of both sides, and we get that T is 21.63. In this case, it would be centimeters. So in our last example, we have triangle MER. We have our right angle at E, and then we know the measure of angle R is 22 degrees. So similar last example, the first thing I'm going to solve for is my missing angle M. Just going to do 180 minus 90 minus 22. And we're going to get the measure of angle M is 68 degrees. Now I want to solve for our missing sides. So our missing sides are going to be r, and lowercase m. And I want to use my given angle r, 22 degrees, and my given side length, which is my hypotenuse, 24. So I want to label my sides r and m based on the relationship they have with my 22 degree angle. So my side r is my opposite side to my angle, and side m is my adjacent side. And then obviously my 24 inches is my hypotenuse. So first I'm going to solve for side r. So it's my opposite side, and I want to use my hypotenuse. So opposite in hypotenuse is sine. So we know that sine of 22 has to equal my opposite side r over my hypotenuse 24. And so in order to solve for r, I'm just going to multiply both sides by 24. And r is 24 times the sine of 22. Now I'm going to use my calculator. So we get that r is 8.99, and in this case, inches. Now we're going to do the same thing for side m, which is the adjacent side, and I want to use my hypotenuse, which is cosine. So we know cosine of 22 equals our adjacent side m over our hypotenuse 24. So again, we're going to multiply both sides by 24, and we get that m is 24 times the cosine of 22, which I'm just going to use my calculator. And we get that m is 22.25 inches. Let's go ahead and do some examples with our special right triangles. So we want to find the remaining side lengths in a 30, 60, 90 special right triangle whose shortest side has a length of 3 centimeters. So in a special right triangle, we're never going to solve for the angle measure because we are given our angle measures. They're 30, 60, and 90. So we'll label our 30 and our 60. So we know the shortest side is 3. So the longest side you have to take your shortest side, 3, and multiply by the square root of 3. So it'd be 3 square root 3 centimeters. If you want to write that as a decimal, that's 5.2 centimeters. And then our hypotenuse is our shorter side times 2, so 3 times 2, which is going to give us 6 centimeters. So seems kind of scary, not so bad. Right. Next, we want to find the length of the legs in our 45, 45, 90 special right triangle if the hypotenuse has a length of 7 square root 2 meters. So the nice thing about leaving our hypotenuse in terms of our square root is that it makes the solving for x a whole lot easier. So we know our hypotenuse is 7 square root 2. We also know that the relationship that exists between the legs and the hypotenuse is that the hypotenuse is the leg times the square root of 2, which means my legs are 7 meters. If my hypotenuse was not in terms of 7 square root 2, then I'd have to do some more math to solve for it. So those were kind of easy type examples, but now let's look at a little bit more difficult. So we're finding the lengths of the legs in our 30, 60, 90 special right triangle if the hypotenuse has a length of 32 millimeters. So we have our 30 and our 60, and we know our hypotenuse is 32. So when you're given, no matter which side you're given in a 30, 60, 90 special right triangle, whether it's the longer leg or the hypotenuse, you want to solve for the shorter leg first. So in order to solve for the shorter leg, we know that the hypotenuse is 2 times the shorter leg. That's how we get the hypotenuse. So we know 2x has to equal 32. So then we'll divide by 2. And we get that the shorter leg is 16 millimeters. And now for the longer leg, we know you just take your shorter leg and multiply it by the square root of 3. So it's 16 square root 3 millimeters, which if you want to think in terms of a decimal, that's about 27.71 millimeters. All right, last one, find the length of the hypotenuse in a 45, 45, 90 special right triangle if the legs have a length of 2 feet. So it's really not all that difficult to find missing sides in a 45, 45, 90 special right triangle because the relationship is actually pretty nice. So my legs are both 2, so we know for the hypotenuse, you just take the length of the leg, which is 2, and multiply it by square root 2. So you have 2 square root 2 feet, which as a decimal is about 2.83 feet. So let me know if you have any questions about solving for missing side lengths or angles in a right triangle or using any of these special right triangle relationships.